Okay, so on this one, we're finding the domain of the rational function, and so they have the set of all x's such that, and what we do on this is we need to set the denominator equal to 0. And so you don't really set the 6 equal to 0 because that doesn't make any sense. You would just say x squared minus 100 equals 0, so x squared is 100, and then you take the square root, so you get plus or minus 10. So for the domain, it's all x's except for plus or minus 10, so we put x not plus and minus 10. Or if you want to be exact, like on this one, it says x naught 10, x naught negative 10. Okay?
Are the answers in the back?
Yes, they are. Yeah, they are. On the review, I give you the answers in the back, so you can check. That way you study something that's valid.
Morning, ladies.
Okay, so there's number 1. Again, all you do is you set your denominator equal to 0. You don't have to set the 6 part. You just do x squared minus 100 is 0, x squared is 100, and so you get plus and minus 10.
Sorry to interrupt. I thought your name would be Grudge Stuff to go to Building 1.
Okay, so again, we finished number 1. Number 2. Let me unfreeze that. Okay, number 2, analyze the graph of a function. First thing is they want to know the domain. And so again, we set our denominator equal to 0. So first thing you're going to do on this is take the cube root of both sides. So we get x plus 4 equals 0 because the cube root of 0 is 0. And so then you get x equal negative 4. And so it's basically all reals except for x naught negative 4. So that's A. On B, what's the equation of the vertical asymptote? We're going to graph it, but it should be the same thing as the domain in this case because the numerator and denominator did not match. Remember, if they do match, then it could be a hole in the graph. So remember, those are your 2 conditions. If your denominator is equal to 0, one condition is a hole in the graph, the other condition is a vertical asymptote. So that's why you need to check. X times x minus 4 squared over x plus 3, 4 cubed. Okay, so sure enough, negative 4 is your vertical asymptote. Again, as a real quick reminder, you could press tab. Let me hit escape first. Okay, so again, if you go to here, if you really wanted to, you could do menu, graph entry edit, and change it to relation. And that's where you could put x equal negative 4, x equal negative 4, and then when you press enter, that's your vertical line. Of course, we know if you had changed this to like negative 50 or whatever, then you could see it's approaching even more, closer and closer, but not touching. And so the equation of the vertical asymptote is x equal negative 4. Any questions? Okay, then it says the equation of the horizontal or oblique asymptote. So in this case, we use the x times the x squared, so we just ignore the negative 4 part. So for our numerator, we have x times x squared, and for our denominator, we just have x cubed. So in this case, that does simplify to x cubed over x cubed, so we do the ratio of the coefficients, and so that's equal to 1. So we have y equal 1 as our horizontal asymptote. Remember, it's horizontal if the degrees match, and it's oblique if it's 1 degree higher. Parabolic would be if it's 2 degrees higher, and so in that case you would just choose none if it were 2 degrees higher. And again, you can check this on the graph. Let me go back to a standard window. And go to graph entry, function, and put 1. So that's your horizontal asymptote. It's not 0 because it's not a proper equation. I'm sure we'll get to that later. And then, oh, by the way, here's a little hint on this one. Whether you see this later or now, you see all these things say y equal 1 on the graph. Well, that's a pretty good hint that it's going to be y equal 1. So you can use this answer to help you answer that. And then this is -4. It looks like all of them are -4, so you can, use that. So the graph we want is C because it goes up there and there. Any questions? Okay. And again, this is section 4.5, number 31, if you want to borrow a book and use it to study and look at that set of numbers. Okay, number 3. This one says find the vertical, horizontal, and oblique asymptotes. What we're going to do is we're going to set our denominator equal to 0. So you get x is -7/4. That's either going to be a vertical asymptote or, in this case, because we haven't factored the numerator yet, it might actually just be a hole in the graph. Okay? So I'm just going to graph it. So we have 20x squared plus 19x minus 28. All of that divide by 4x plus 7. Okay, well that's just a slanted line, and so there is no vertical asymptote. No vertical asymptote is slanted. Okay, so we choose no vertical asymptote. There's also not a horizontal asymptote. And then what you have to do is figure out what the oblique is. And so remember, there are 2 ways to do it. One of them is to practice factoring. The other way is to do long division. So whichever way, they both work. The reason why I already know to start with 4x plus 7 is because it was a hole in the graph, and so it shouldn't be that bad to factor it. So let's use 5x here, and then I guess just guess and check. This is 20x squared. Okay. Well, I said it wasn't that difficult to factor, but we've got a 20 and a -18. Okay, I'm going to do long division instead. So let's start with 5x. So we get 20x squared plus 35x. Remember, when you're doing your long division, you subtract. And so 19 minus 35 is negative 16. So we get negative 16x. Then you bring down the negative 18. And if you have 4x and negative 16x, then we need a minus 4 here. So this would be negative 16x minus 28. Again, you're subtracting, so this cancels, and this would have a remainder of 10, which we don't really use. So the 5x minus 4 is what would go here. And by the way, if we just want to check that, and we did 5x minus 4 here, then our middle terms would be negative 16x plus 35x. Negative 16 plus 35 does give you 19, which is what our middle term was. And oh, I see why I got confused a little bit earlier. It's because this says 28 and I put 18 there. If I would have seen that, that would have been easy to factor. Okay, sorry about that. Because I know 7 times negative 4 is negative 28. I think in general factoring is going to be quicker than long division, but depends on the person. Any questions?
So that means we would have a remainder of 0, right?
We have thank you for, since I updated this, I forgot to update here. Yeah, we should have a remainder of 0 in this case. Thank you. Yeah. Okay. Any other comments or questions? Okay. So that was number 3. Number 4, use the graph to find all of these things. So our domain is going to be all real numbers except for that, which looks like negative 2. So x not equal to negative 2. The range would be all real numbers except for positive 3. So y not equal to 3. The equivalent way to write it is y greater than 3 and y less than 3. But what they prefer is just y not 3. So the range is where you have your horizontal asymptote. And so in this case, it's just y not 3. Any questions? Okay, then for the x-intercepts, it's at 0. Well, it's at 0, 0, but it just wants an integer or a fraction, so we put 0. Don't put 0, 0 there. And for the y-intercept, it's the exact same thing, since it was 0, 0. And then the horizontal we said was at 3, and the vertical at negative 2. Yeah, all the answers are A, but then you got to put the numbers. Yeah. Yeah.
What's the x?
Negative 2.
Were you supposed to circle something like at the very top?
Circle.
Oh, okay, I don't know. Like up there, very top.
Oh, this just lists the questions, and then this just has them broken down individually. So you don't have to do anything with this part. Okay.
Is it just telling us what?
Yeah, it tells you what's coming. Yeah. Good question. Okay, any questions? All right. Then it also wants this last part. It's broken up here where it says find the oblique, but in this particular graph there is no oblique, so we just choose B. So that one has B as the no oblique answer. Okay, the next part says analyze the graph of the function, and so what we're going to do is set our denominator equal to 0. each of the parts. So x minus 7 equals 0, so x is 7. X squared minus 16 equals 0, which leads us to plus and minus 4. So it'd be all three of these. It's not 0, so it can't be A or B. And 7 and plus and minus 4. So that's C. By the way, this would be an example of one that's proper since the denominator's greater. Has a greater degree. Change this to has. So that means it's y equals 0, which is the same as the x-axis for your horizontal asymptote. This part is about the vertical asymptotes, so it's going to be all of those basically. So it's 7, 4, negative 4. And the horizontal would be at y equals 0. Then we just need to graph it. Remember, you may want to change your window to be like these to make it look exact. So 4 divided by x minus 7. Notice right there I had to do a double open parentheses. So I go here and then x squared minus 16. Yeah, that way it'll show up properly. And then based on the window settings, it should be from negative 6 to 11 on all of them. Let's just go to the window settings. Negative 6 to 11. And then this looks like negative 0.37. Or is it just, negative 0.37. Negative 0.37 to positive 0.37. Okay. And then, let's see. Is it D or is it? Yeah, it's D. You're right. Good job. Oh, because of this part. Yeah. Yeah, and it's upside down. Right. Okay, good job.
What was,
Yeah, but okay. All right, cool. Okay, very good. Yeah, and so again, I know I mentioned this earlier, but if you look at some of the graphs, they really could help you on this test because all of these say 7, so 7 would be one of your vertical asymptotes, and like that. So there's a lot of hints in here. Okay, the next one. 3 over x minus 1 squared. So again, this one we just want to graph it, but you're going to have a vertical asymptote at positive 1. And so it's not going to be these, and so you're going to choose between these two. We know that when it's x squared and it's positive that both are going to go up. So it's just a matter of how close is it when you have from negative 3 to 5. So 3 over x minus 1 squared. Okay, so that looks like the C graph. Any questions? Okay, this one, this would be an example of parabolic because it's basically x to the fourth over x squared. And so I know later on in here we're going to say no horizontal or oblique. P-A-R-A, let me write it over. P-A-R-A-B-O-L-I-C. In other words, it's going to be x squared, which is quadratic, and so it'd be a parabolic asymptote. Okay, so for A, the domain, again, what we do is we set our denominator equal to 0, and so x is going to be plus or minus 5, because you put the 25 over here and take your square root. It's not 0. Then the vertical asymptote would be at the exact same spot in this one. So we put negative 5, positive 5. Because you can't factor the numerator and make it match x minus 5, x plus 5. So that's how we know for sure it's a vertical asymptote. And then it's no horizontal or oblique. And then as far as the graph, let's just do that. Add graph, and we've got x to the fourth plus x squared plus 9. Whoops. Plus 9. Divided by x squared minus 25. Okay. And then the next part is all of these say negative 12 to 12. Whoops, not table. Window settings, negative 12 to 12. And then some of these say negative 210. This one says negative 105. So some of them say different numbers, and then flip that. So I'm just going to make it the absolute lowest, negative 210, bless you, and the absolute highest, which is positive 210. And just look at that. Okay, so it's going down in the middle, so it's not this one. And yeah, it's not this one. And yeah, that's D. It's a D graph. Very good. Okay, number 8. The domain for this one, again, what we do is we set our denominator equal to 0. This is one I don't really feel like factoring. So you could either, well, you could do factoring, you could do the quadratic, or you could do the x-intercept via the graph. And this is going to be the method that I choose for now. I know we need an integer or a fraction, so let's just try to make it easy on ourselves this way. So we're going to do 4x squared minus 27x minus 7. Okay, so there they are. Menu, analyze graph, 0 the graph. So from here to here I get negative 0.25. and menu, analyze, zero the graph from here to here is 7. Now, since it wants fractions, then you have to convert that to a fraction. And the way you do it through the calculator is through the calculate screen. And you can say negative 0.25, then press menu, number, and then approximate to fraction. And that's negative 1/4. So you end up with negative, well, I need a x naught equal to first. X not equal to negative 1/4, comma, x not equal to 7. Not negative 1/4 and not 7. Okay, let's do this one also. Graph using transformations. Well, really all you have to do is type this in and graph it. But if we use some of our properties, we know that this part would have a horizontal asymptote at y equals 0. This part indicates it's at -3, and then you do 3 plus 0 to get, well, sorry, -3 plus 0 to get -3. So we know overall, before graphing, that you're going to have a horizontal asymptote at -3. In this case, the part on the right just is a proper, so that's y equals 0, and then this part is the vertical adjustment. So that's the C graph at -3. Oops, new document. -3 plus 1 over x. Okay, so there it is. And again, you can do tab and then -3. There it is. All right. For right now, we're going to stop right there since we're on pep rally schedule. Don't forget to do your reflection. It's due tonight. And you have Math Excel due also.